Good afternoon, everyone. After the lunch, I hope you'll stay awake to listen to the new developments on the Alternaria late blight of Pistachio. So today I'm going to emphasize the resistance of these to fungicides. As well, at the end of my talk, I will mention something about a prognosis that I have for the pistachio industry that is based on the changes of the weather. So, for diseases, we're very lucky here in California. We just have 3 diseases. One is the Botrytis panicle and shoot blight. That is a disease that almost devastated the industry 40 years ago. And the second disease is the Alternaria late blight. And then the third is the Botrytis shoot and blossom blight. So the Botrytis disease was discovered in 1984 in Northern California in very few orchards. And in about, about 10 years following heavy rains in the springs, it became a major epidemic. And in about 12 to 14 years, it spread throughout the California. And thanks to the pistachio industry and the efforts and the funding, the trials and the fungicide tests that are done over the years, nobody's talking about Botrytis any longer. So, the second disease, the Botrytis blossom shoot blight. This is a very occasional disease, occurs when we have rains, cool and wet spring. And if we have some rains in late May, early June, then you'll get some fruit infection. Mainly, this disease damages the male trees, but also with the right conditions can damage also the female panicles, and shoots can create shoot blight. This is easily controlled with one spray in the spring, but as I said, it needs very special conditions in order to become very severe. And now let's come to the subject of today's talk. In 1985, the first report we submitted to the pistachio industry, we had a question regarding this disease, if this Alternaria on pistachios, if really it is a disease that will damage pistachios. In about 40 years now, we have this disease as a major disease throughout the areas where pistachios are grown, and it is one of the most difficult diseases to control because the pathogen develops resistance very quickly to various fungicides. So just to remind you, the symptoms here, we have the foliar symptoms, necrotic lesions on the leaves that under high humidity in the orchard, those lesions will sporulate, will have sporulation on the, we'll have the sporulation, this is too far from here. We'll have the sporulation on the lesions that we can rub them with your finger, and you can, your finger can be black, and this is a characteristic that we use to distinguish Alternaria lesions from lesions caused by Botrytis. Of course, most of you are young people now working with pistachios, and you have not seen the symptoms of botryopsphere, what botryopsphere can do. But probably, and hopefully, all of you know about the Alternaria symptoms on pistachios. So do not confuse this with the Peter scourge, and we still have samples submitted to the lab of Peter scourge, which is kind of necrotic lesions on male trees mainly, but it can be found on female trees. And these are very clean lesions, no sporulation. However, later in the season, with the irrigations, etc., these lesions can be colonized by saprophytic fungi, including the Alternaria, and then it becomes more confusing. But if you see the symptoms in June, it is the Peter scourge, and it is not Alternaria, because the Alternaria symptoms develop much later. And in addition to necrotic lesions on the leaves, we also have the whole decay by Alternaria, and that is where the problem it creates this problem by the decaying the holes. We have staining, and as I will report in a moment, we also have crop losses from Alternaria, significant with the changes with the rains in the summer. So it starts, the decay of the hole starts with the these lesions on the holes, and then the fungus will grow, will decay the entire hole, and then growth of the fungus can be on the shell, and both the deterioration of the holes and the growth of the fungus will stain the shells, and that's a major loss of quality of the pistachios. Now, this disease causes severe defoliation. You can see that these necrotic lesions result in the leaves to defoliate fast. And there is a big difference between the two varieties, Kerman and Golden Hills. The Golden Hills is more susceptible, it defoliates much earlier than the Kerman. And apparently the disease, although we call it late, now with the Golden Hills can be characterized, we can eliminate the late, actually, can be seen much earlier. We can see the symptoms much earlier. The pathogens, we reported on these years ago, 3 Alternaria species, but the main Alternaria species is the Alternaria alternata, which is very, very abundant. And these are the factors that affect the Alternaria. The pathogen is airborne, first of all. It's all over the place. It's in nature, it's abundant in nature. The inoculum builds up during the season. And I will show you a graph on this. And as you know, the relative humidity in the orchards increases later in the season. And relative humidity in the orchard is the triggering factor for the Alternaria to develop. And in addition to this, also the physiology of the leaves changes, and we have the leaves senescing and they become more susceptible to the expression of the symptoms of the disease. Here is some of this I mentioned. When you have the a canopy like this with a very close canopy, you can see the shade here, it's unique here, continuous shade in the orchard, very high humidity, and we show in experiments that as we increase the duration of the humidity, the Alternaria lesions increase exponentially. And also when you create a lot of dust here in the orchard, you increase the amounts of the Alternaria on the canopy. And you can see in this graph here, in this graph, as we progress in the season and we get more dust in the orchard, on the canopy, you get more Alternaria on the leaves on the tree. So all these are factors that really influence the development of Alternaria. I mentioned that it is very difficult to control, and that is why we started with cultural practices and also chemical fungicides. And those two work well, but for the biological compounds, we do have major questions. So far, as far as I know, not really reduce the disease to significant levels. So for cultural practices, we developed several recommendations here. Choose the right cultivar. Of course, if you have an area where it's very conducive to the Alternaria development, Caramon is the choice, but other factors like the economics, etc., can make you choose Golden Hills, which is more susceptible to Alternaria. Increase the infiltration in order the soil infiltration in the orchard, and this can be done with gypsum. Amend the soil with gypsum, and that also contributes to reduction of relative humidity. Increase the ventilation in the orchard, and that can be done with orienting the rows from north to south. Proper pruning, that is open the trees, not let the canopies really reach to each other and have closed canopies, and that will create a reduction of ventilation and increase of humidity. And use the appropriate irrigation. Irrigation with drip irrigation will have less humidity in the orchard, and avoiding the excessive dust. And as the previous speakers talk about dust, here's another example where reducing the dust will reduce the inoculum on the canopy of the trees. For chemical control, you are familiar with the fungicide tables. We have a lot of fungicides registered with excellent and good control. You can see 5 and 4. And as I said, the biologicals are not really doing any benefit for Alternaria. But still, here with fungicides that we have 5 or 4 score for excellent control or consistent control, we do now have the efficacy of these fungicides in much lower numbers. And this is because the pathogen Alternaria developed a resistance to the major groups of fungicides. What is resistance and how it is developing, how is resistance selected? Let's say we start with a population that is merely sensitive, the Alternaria here, you can see, but still in the population there are some mutants that have mutations that will resist fungicide applications. When you apply the fungicide, all the sensitive population will disappear. Well, not all, a few will survive, but the resistant, of course, will survive. And then they will multiply the next season, and we'll have a lot of sensitive again, but a little more mutants. Then with the next application of fungicide, we'll reduce the sensitive population again, but not the resistant, and then going on and off like this, with the fungicides and the different cycles of reproduction of this fungus, will end with a population with the black dots, which are all the mutants, which is the resistant population that will, the fungicides will not have any effect in affecting them and reducing the disease in that way. So, and because of this fact that this pathogen develops resistance to fungicides, and the first effective fungicide that was registered was in the FRAC, the Fungicide Resistant Action Committee Group 11, which is the strobilurins, and were very effective, but they lasted for a couple of years. Then we started questioning, well, let's see how much resistance developed in a couple of years after the application of strobilurins for controlling Alternaria. So we did studies in which we collected samples from different orchards, mainly from the San Joaquin Valley, and some almond orchards, because the almond has the Alternaria leaf spot. And we found out, indeed, more than all the orchards of the almonds, because they've been using a lot of sprays for Alternaria, they had more than 90% of the population was resistant. And in our pistachios, 84% had populations with more than 90% isolates resistant, and the other 16 with less than 90%. But 90% is really high for resistance levels in the fields. So the resistance to strobilurins became very widespread in a very short time. And to overcome this resistance, then companies started mixing different groups, like taking here an example, Pristine came with the pyraclostropin frac 11 and Boscali with frac 7. This was used to overcome the widespread resistance to QIs, to strobilurins. And we saw the same story here. The Pristine was very effective for a couple of seasons, and then a resistance to Boscali started developing in 2 to 3 seasons. These studies now force us to develop techniques to analyze isolates, to analyze the resistance directly from field samples. For instance, when we started with the frac 11 strobilurins, we developed a qPCR technique where we collect the leaves from the field, and immediately in a couple of days we can say the levels of resistance. The same studies were done with the frac 7, which is the SDHI, the other group of compounds, and we completed the same type of technique, a Q quantitative PCR. In other words, we quantify the DNA of these compounds, of these isolates that is resistant to these specific groups of fungicides. And now we're working with the qPCR technique on the demethylation inhibitor fungicides, DMIs as we call them, frac 3 in Alternaria cultures. We're successful to analyze this with Alternaria cultures, and now we're moving into using directly field samples, leaves with lesions of Alternaria. So with these studies, what we do is this technique really detects the mutations. For instance, for the strobilurins, we detected 2 mutations, among which the G14G3A is the most common. Okay, the resistant isolates will have that mutation. For the other group, the frac 7, we had about 5 mutations, but you can see those with the red. The H277Y and H277R are the most common. And for the DMIs, it's a different type of test here. It's a gene, CYP51, that is in a gene that, in this case, instead of DNA, we detect this in the RNA of the fungus. We want to see what happened after almost 20 years after we started this resistant studies, and we found out, for the frac 11, for the strobilurins, when we analyzed the orchards for resistance, we had about 30 orchards, most of them in the San Joaquin Valley. You can see here that the scale, the darker the circle, the more resistant isolates, the lighter the color, lesser resistance. You can see most of the high resistance fields are located in the valley, Well, the west side has less resistant isolates. The incidence of resistance is lower. And you can see up here in the Northern California where we have controlled the botrysphere, and now they have major problem with Alternaria, and they use a lot of fungicide sprays there. The resistance is really high. But notice here that the gene that is confer this resistance is the same gene, G144.3, after 20 years. In contrast, when we check the FRAC7, remember the most frequent gene there was the R277Y and the H277R. And now, instead of that gene, we found a different mutation, the H134R, which indicates to us that this fungus not only is easily is selected for resistance, but also has the ability to change the mutations to withstand these, the fungicide sprays. Again, with the same type of results here, sorry. The same type of results, again, we see the darker color, higher levels of resistance in the valley, the west side. Once we used to call it the disease-free area, but I will explain why it is not anymore disease-free. We have lighter, lower levels of resistance in Northern California, and this is for FRAC7, the SDHA compounds, and you can see we have a widespread resistance for this compound as well. So you can see now with this trial here that the H134 mutation is very common, while the H277R, they're not very common anymore. So the fungus has changed the mutation to withstand the FRAC7 fungicides. So two mechanisms, not only selected, creates mutation, but the mutations can change over the years. And that's the mechanism this fungi developed to survive in nature, regardless of what we do. So for the other group, or major group, the DMIs, we have the procedure worked really well for the resistant isolates. 15 of the isolates shows the expression of this gene. These are the resistant isolates, and 15 sensitive isolates do not express this gene. And so the next step is, of course, to collect leaves with lesions and apply this method with the actual real samples from the field to make the process available to the laboratories, and they can analyze the results within a couple of days and get results quickly. We did studies for efficacy, and now this is from 2023, and the more yellow you see, the better control of Alternaria. Here in the x-axis is the proportion of trees with Alternaria. And here are the different fungicides. The ones with the red arrow show the FRAC3 fungicides, which show effectiveness against the Alternaria disease. Also, these colors here indicate the severity of the disease. The control, of course, is more severe than the yellow, which is less severe disease levels. This is to show you that the FRAC3 still is effective in reducing Alternaria. In fact, in 2025, you'll ask me why I do not show the 2024. As Steve reported, in 2024, we had 2 weeks of 105 Fahrenheit, and this disease did not develop in the field, in that field that every year we had disease, except that year. So there is something there that tells us that these high temperatures really reduce the disease so effectively. So we do not have any results for 2024. But 2025, very interestingly, we use some biofungicides here. You can see here, very little reduction. But one fungicide that really stood out was the Red Jeff. It is a combination of difenoconazole and tea tree oil. And also, we did a trial with a vellum that was injected in the irrigation, and that was really very effective. We treated one row of trees. Were outstanding. So we have compounds that now really reduce the disease very significantly. But again, there's the same effect here. You can see the arrows here indicate FRAC3 or fungicides that have FRAC3 as a component in the treatment. So you are familiar with the fungicide tables, and in that we have the rules that Jim Madaska has really developed, and it applies really well here. That general rules: rotate or mix the fungicides with different modes of action. Use label rates. Do not reduce the rate of good coverage. And limit the number of applications of any fungicide group. Okay, educate yourself on fungicide resistance. There is a lot of information in those tables. The first page is there, they're more general. And select fungicides with multiple multiple sites activity. Climate change, a few minutes left. I'm not going to talk to you about climate change. This is happening, you can see it. If you check the definition of the characteristics of the climate in San Joaquin Valley, it says that it is a hot and arid and clear conditions with virtually no rain, and rain in the summer is minimal or to not happening. However, in the last decade, and in fact during the last 5 years, we see a lot of differences. Between 2022 and 2025, we had rains in the summer. All of you remember the Hurricane Hillary, and then rains in September, October in 2025, very unusual. In some areas, really got a lot of rain. Now, with these things happening, the areas that I was calling them disease-free, like the west side, this is a west side orchard close to Highway 5, severely affected after the rains in August, the Hurricane Hillary with Alternaria. And that is the orchard where the grower lost not only the quality, but also lost 25% of the crop. In 2025, we had rains also late, and rains September in Terra Bella area. There we had something very, very complex, very puzzling, because Alternaria developed, but also when we collected these clusters, we had major infections by Fusarium, Trichothecium, Penicillium, other fungi, opportunistic fungi that took over also at that stage. Now, with these changes, with rains so late, close to harvest, in Arizona, for instance, they have the monsoon rains, they have a major disease, and my prognosis is that this disease eventually will come to our pistachios. It causes very severe defoliation, very damaging. The other disease that they have is very similar to anthracnose, a very devastating disease. It's a form of blight and causes, the decay of the hulls and the infection of the nuts. It doesn't kill the clusters, but it stains the nuts, and perhaps this will be a lot of damage by this disease. In Australia, they had rains during their summer, close to harvest, and the major disease there was the anthracnose. A lot of damage. I was saying 50% the one of the directors of the pistachio industry there said no, it was 75%. So in California, we have this pathogen. It did not develop. It was discovered in 1998 in Tulare County, and then in 2016 up in Northern California. It developed in some varieties like Jolie and Red Aleppo, and a little bit on Kerman. But with the new varieties now, I do not know what will happen with the late rains, the new varieties, if this disease will really develop to become a major disease. And in Mediterranean area, where the countries there, they have another major disease, the rust. We haven't seen that here in California or in other states where pistachios are growing, but these are the diseases that I expect to see after following this type of rains. So to close here are the general conclusions. Again, I want to emphasize that both cultural and chemical control is necessary for Alternaria. And you have to remember the message here is that we have to include the DMIs, the FRAC3 compounds, or fungicides that have as a component the FRAC3. Even for the almonds, Jim Adaskevich recommends FRAC3. You can see how many 3 are highlighted in this slide. So, and the other thing is, because we have such a pathogen, the Alternaria not only develops resistance but changes mutation. This is will be a very, very difficult disease to control. And the summer rains, they have changed the situation here. The disease-free areas becoming infected with diseases. And my prognosis is that the Alternaria probably will expand even more. Botryopsphera may come back, and I suspect the septoria and anthracnose and lymphoma, maybe rust will be, maybe there will be a major disease in the near future if the weather continues to become, to be like rains in the summer, close to harvest. And with this, I would like to stop here. Thank you.
Great. Thank you, Themis.
Thank you.
Greatly appreciated.